Welcome everybody. Ramanathan. I'm a product manager with Google. I cover some of our machine learning products. And my topic today is talk about how we can apply machine learning to drive better content discovery. So that's really the focus. We'll talk a little bit about, in general terms, around some of the techniques that's available, and particularly cover some of the products that we have in Google Cloud and facilitate some of these aspects. So the key aspect is if you think about Google today, we have properties like, let's say in YouTube, we have over 400 hours of new content added every hour, and we have billions and billions of hours of content on the platform. How do we recommend the right piece of content to the right user at the right time? All right? That's a common problem that we face today in Google. That's a lot about content discovery. And if you think about aspects around Google Play Movies, where we display so much metadata about the movies, the actors in the movies, as people watch it, so they can make better decisions on what's the right movie that they should purchase or buy. And if you think of other properties like in Google Photos, you think of photos as consumer products, but it's a lot of, actually more and more what people create is more than images. They start dealing with video content. How do we start curating? How do we create video highlights? How do we create video previews for all the video content that people produce on their smartphone cameras, which is prevalent all over the world? And that's really what we want to talk about, is how can we apply these different techniques to enable people to discover content. You know, the video content overall is exploding, right? I think YouTube just had a blurb sometime back around how over 1 billion hours of content is watched every day, right? That's just, and I think Cisco had an article talking about how by 2020, 70% of the internet traffic will be video content. Basically, video content is exploding. But we have not so far treated as dark content. I think our VP, Faye, talked about how video content, for the most part, once you create it, once you distribute it, it's really just kept there in these massive content archives that most media publishers have no clue what the content is, right? They have very limited metadata on that content. How do we discover what's in that content? And that's really what we want to talk about. How do we facilitate that? We've solved this problem, or have solutions to solve this problem with structured data. All our organizations have things like ERP systems, CRM systems. We have transactional systems that feed into a data warehouse. People run SQL query all the time to find aspects, what's going on in their regular business. But when we think about video content, we're still treating it as this big black matter. We store it. We have some limited metadata that we use to push content out, but we really don't understand anything what's inside the content automatically. And that's really what we want to solve for. So things that, from a Google perspective, how are we approaching this? We're approaching this in two ways. We're providing you a platform that you can build your own machine learning models. I think Anton had a really good use case about using natural language processing to do some very intelligent aspects on textual content. And normally what you would do that is you need a machine learning framework. You need a machine learning platform that you apply on your data set, and they provide a model out of that. So we have partnered with Google Research to open source TensorFlow, which is the #1 ML platform in the market today. It's open source. And we have a managed platform. You can run it on the Google Cloud. Or you can run it in any cloud or on-premise. And on the other side is we offer ready-to-use APIs for you to consume this content. We'll talk a little bit about what does it mean to consume these APIs in some demos. So the things that we feel that machine learning can help you on your video content is 4 aspects. One is, how can we find easily using machine learning to find out what are the main topics of what a video is about, what are the key entities of actors inside the video, how do we automatically discover that for you, right? For example, how do we track faces, how do we track what entities are in the video, and decipher the metadata out. Clearly, it's not going to be as good as manually metadata tagged content, but the question is, if you have petabytes of this content, can we apply machine learning to get that metadata and then drive it so you can make some intelligent decisions? That's the goal. The second aspect is if you start thinking about crowdsourced content, where your consumers or your users are creating content on the fly and they're uploading into a distribution platform, how do you moderate that? Right? How do you drive appropriate audio cues, video cues to protect yourselves against inappropriate content that you then distribute to your customers? That's a common problem. We want to, how can machine learning help you in that? The other aspect is highlights. Highlights is a common issue that we have. How do we think about what's the right shots within a video that we can create a video preview for? Right? How do you entice a customer to watch that video? If you think about YouTube, that's a common problem we have. Right? We have billions of hours of content. We can only show 25 videos at most, and for each 25 video, we have only like maybe 2 seconds of that consumer's attention span. So we want to show them the best highlight, so we entice them to actually watch it. Like, how do we solve for that? And the fourth part is how do we start thinking about language? There's so many things around what people are talking about, what people are talking about in the script. I think there's some interesting use cases that Anton talked about, but how do we make sense of natural language inside the script itself? So let me kind of walk through some demos that we're talking about, what I mean by things. For example, this was something we showcased at Next couple of weeks back. In this case, let's assume that we have a media portal. So we have potentially, in this case, we have 100 videos, but let's assume we have petabytes of content. And you want to find videos that have baseball. The normal way to do it is you most probably would have hired an intern or a bunch of interns to go and catalog every single video. With this, we've just applied machine learning on the videos. And for example, in this case, we have a video which is basically our best of Google search. And we found a clip that has the Cubs winning the World Series. So we have a clip inside the video, and we find the exact shot in that video when it occurs. Another aspect is, for example, let's say we want to search for, people are trying to find commercial entities. In this case, we want to find, hey, is there potentially a Volkswagen Beetle? So you find an exact clip in this video when that occurred. Out of the box, basically all we did was apply the video, a new product video intelligence API on the video. You could apply it in other kinds of video too. For example, in this case, this is an ad that we're using for Google Fiber, and we automatically kind of walk through the ad, and we think about, as the ad progresses, we tell you what's in the video at that point in time. It's basically metadata we can drive. This is more general kind of metadata on entities, but you can imagine over time, what we want to do is work with partners to provide more specific entities that are occurring within the video. Right? So in this case, we detect all the shot changes, and within that shot, we tell you what are the relevant entities within the video. Another example is, for example, in this case, similar scenario. This is a spoof video that we did for an April Fool's joke, where basically we kind of walk through this video. We kind of tell you what's occurring within the video, who's talking, what's happening within the video, and we drive those aspects of it. Let's think of other pieces where this might make more sense, right? Let's think about images. That's a common issue that we have. For example, there's a lot of metadata on images that flow through also. So in this case, let's take an example where let's say somebody takes a picture of, you think about publishing, syndication, think about those pieces of how you kind of merchandise from your media content, how do you make sense. In this case, somebody takes a picture of a cup with some clearly Rogue One characters. We, from a machine intelligence perspective, will automatically find out that this video is actually has Jyn Erso in it. It's tied to Rogue One Star Wars out of the box, because we basically scour the web to find out, hey, is this image occurring anywhere else in the web? And we can find out about that out of the box for you. Another example is, for example, you may have things like celebrities, and then you want to find out, hey, who is a celebrity within the thing. In this case, what we do is we automatically scour the web, where we will find out, for example, this is a picture of Brad Pitt, he's in the movie Fury, etc. The way we do that is we use the power of the web to drive this metadata. Does that make sense? Google does not have our own celebrity recognition model. What we're using is, in the web, there's clearly a picture of Brad Pitt somewhere with this picture, and we basically get the metadata from the web and drive it. So Google themselves, though, we don't have any models or any biometric information about Brad Pitt. We're just using the power of the web to get information about people. And normally, famous people have lots of images about them on the web, so we use the web to drive the metadata. That's an example of how we can use the web to think. And you can imagine, this is an example of what we can do with images. Or anything related to machine learning and machine perception always begins with an image of cats, because you can never have enough images of cats. I'm not a cat person, but cats drives a lot of our machine learning techniques. But you can imagine, I give you an example of images because you can then think about how we can apply that on video content also. You can think about, we do labels, you can do things around OCR. For example, we have customers trying to actually figure out, use cases are not media specific, but thinking about how can we pull text out of image streams coming in for things like surveillance scenarios, etc. So how do we enable those scenarios? You can imagine that over time will help you detect in video content logos. You can imagine brand logo placements are a key aspect. How do I find out? In this case, we can automatically detect things like Android logos, but you can apply that to this whole universe of brands that's out there. How can we more intelligently detect brand placement in video content? Right? That's a common problem that many marketing organizations have as they start doing product placement in video content. How do we facilitate that? The other part is, I think when you think about is natural language. So in this case, the two things that we want to talk about. One is speech. We do offer a speech API that automatically does speech recognition. I'm sure many of you have an Android device. Every time you see an Android device, you say, OK, Google. That's using speech recognition for us to transcribe what your action needs to be, or using Google Home. So you can imagine applying that on video content, and I'll talk about the use case of how that works. But what I want to talk about is how you would take the text that comes out of speech and do something with it. Right? In this case, what we're talking about is what we calling is named entity recognition. Basically, we have a block of text. It's pretty innocuous, and we want to find all the organizations, basically all the proper nouns within this piece of text. Who are the organizations? Who are the people referred to? What are the locations referred to in this piece of text? Right? So you can do that just as a regular machine learning call. We get you the information, and then we can find things around the sentiment. Was it a positive sentiment, negative sentiment? If you think about the couple of use cases for that, right? You can think about just understanding how are people perceiving your piece of content in the outside world, whether it's movie reviews, whether it's reviews on media sites, in the blogosphere, in social media. How do I figure out what people are talking about me? So really, sentiment analysis is a key aspect of that. And also understand what are people talking about my piece of work in that context, right? Which entities, what are they talking about, positive, negative. Another fun thing you can do with that is actually build relationship graphs. In this case, I search for Tywin Lannister because I'm a Game of Thrones junkie. And basically, you can now find out who is Tywin Lannister related to. In this case, he's clearly closely related to the concept of Game of Thrones. What we did here was we basically grabbed all of Wikipedia's content, and we ran it through our APIs, and we basically figured out which two entities are most related to each other and what's the strength of their relationship. Does that make sense? Because based on how often they join together. So in this case, for example, we clearly related to Tywin Lannister is clearly related to Game of Thrones. He's also clearly related to things like Peter Dinklage, the actor who plays him, and those relationships with Tyrion Lannister. You get the context, right? Now, why will this be useful? Well, let's take that you guys are publishing media content of all the different actors, organizations, directors. Wouldn't it be useful to recognize when people are talking about this movie, what else are they talking about in the context of the article? What other pieces are they referring to? Is it in a positive way, negative way? So you guys can get a better handle end-to-end of what's occurring within your organization or externally. Like if you guys have lots and lots of, say, transcriptions that you already created, you can easily do an analysis on that. So in the future, when you want to distribute some content, you can actually look at, based on the transcription, distribute the right piece of content. Because you can do a search on that. So let's come back to the slide. So this is just a quick view. So what I walked through here was first talking about how we can use video content. This is stuff that we ship out of the box. We'll be working also with the rest of the Google family of products with things like Envato, where you guys can consume some of these pieces. We talked about our natural language aspects, how you can consume that. We didn't talk about speech, mainly because doing a real-life speech demo of speech recognition in this large room can go 50-50. And I don't want to take a 50-50 chance. But for the most part, you can imagine speech is a key scenario. Now coming back to how this works. So basically, you can imagine all these functionalities are available to you as REST APIs. So think of what I mean by REST is it's a web endpoint. You call us with a simple JSON response. We give you a bunch of JSON back. It's still a bunch of JSON that you guys need to figure out what's in it, but it's basically, we kind of hiding a lot of the ML complexity behind the scenes. You can still go and create your own ML models using TensorFlow, and we enable you to do that. So if you guys have a set of data scientists on your staff, we give you an end-to-end machine learning platform with TensorFlow and Cloud ML Engine. And then we get you a bunch of responses back. So in this case, in the video, what you would have got is, hey, this entity called elephant is present from this time to this time, and it's directed directly to the shard boundaries. So a couple of things that way we want to think about when you start grabbing entities from video is you really want to think about there's a video level context, which basically means what is this video about. And normally that makes sense only in the context of maybe 1 to 5 minute videos. Because if you think of a motion picture movie or a TV show, which is an hour long, hour and a half long. There's so many scenes and themes within a video, the ML is going to get confused over time. So normally it makes more sense when you think about video level, what is this video about? It makes sense to think about it at a short video. So really think about 1 to 5 minutes, kind of homogeneous content. The other thing is really thinking about short level. So think of shorts as a mini video in the case of ML, right? So we're saying, what is this scene about, right? And that's really where I think, so imagine if you break a 60-minute video to 1-minute scenes, then you think of that 1-minute scene as a mini video, then it becomes more relevant where we can say for this scene, this is what this scene is about. Here are the relevant entities in that scene. And that's really where I think some of the things that we're trying to enable there. And the third aspect is just thinking about frame level entities. And this is what you can do with images, right? You basically you sample at 1 FPS and run that frame against an image model and say, hey, what occurred at this point in the video? That's a little less interesting. It really only makes sense for surveillance scenarios where you really don't understand too much context. But for media content, you really want to start thinking about short level entities or scene level entities. Within this scene, what is most relevant for me? And that's really what we want to enable. And I think that's where I think you can see, because the problem is machine learning can be good and bad. And part of it is how do you, because if you do frame level entities, machine learning enables you to do that, but then you're buried under noise. So if you think about a 1 hour long video, you're going to get 3,600 entries back. And it's up to you to figure out what's the right thing for me. So that's why you want to start thinking about short and scene level things where you can start aggregating this information out of the box so you figure out what is relevant for me within the scene. Let's think about some use cases how you would apply ML, provided we can do content discovery in your scenarios, right? One common aspect we get from customers is recommendation, right? The YouTube case, so if you imagine, a user really, in the end, out of all the billions hours of content, we provide to you 25 videos to see, right? That's the key thing, because a user cannot navigate all the content you have, and that's becoming a bigger and bigger problem because surfacing the right content at the right time is crucial. So the way you can imagine that is, for example, in this case, this is the example using the Google products, but you can imagine where all this content is sitting in Google Cloud Storage. You run it through our video intelligence product, we get metadata out of it, and then you drive a recommendation model on top of that, right? Really thinking about what are the top 25 videos that people have to use. And this is actually what we do in YouTube. There's actually a YouTube white paper you guys can refer to. This is actually, for example, we first look at this huge corpus of YouTube content that we have, and we kind of do what's called collaborative filtering with the user behavior and a metadata to figure out an initial set of hundreds of video hours of content. And then we do a subsequent ranking to say, out of these hundreds of hours of content, we think this user really wants to only see these 25. And it's important that we give the right 25 is because there's a concept of clickbait, right? Just because I watch one cat video, I don't want to keep showing cat video, cat video, cat video. Because sooner or later, the person's going to click off and not watch cat videos anymore. Unless that person only watches cat videos, right? So you really want to understand what the user is doing and drive the right. So it's really not just important about time to click, predict to click. It's also predict to how long you're going to watch a video. That's important. Another example is building media portals, really thinking about how do you more intelligently drive video summaries, how do you more intelligently drive aspects. So in this case, you can imagine you can automatically, how do you use ML to figure out what the right level of video previews you want, package that, figure out, for example, how do I create intelligent thumbnails, how do I create clips of that video, and then drive that through a distribution through our app engine, right? So it's thinking about how do you build those portals out of that. And the third aspect is how do you think about global distribution of your content. And this, I think, is more aspirational than thing. But you can imagine at some point in the future, we will have, we're working on a speech API which does captioning, right? You can imagine you can use ML. It's not Google, but you can imagine speech recognition is going to get better and better. And at some point, you can use machine learning to do the captioning for you out of the box. Clearly, it's not going to be at the same level of quality as a human annotated context, but for some scenarios, it may work sense. And then you can then think about translation, where you use machine learning to drive downstream scenario translation, and you can then package that content for global distribution. Or you can also use natural language to do some of the analysis I just talked about to have a better understanding of what's been spoken about at what point, and you can do more intelligent searches also. So really thinking of how you can apply different machine learning techniques from speech recognition, natural language understanding, video intelligence, all to get metadata about your content, and then do interesting things with that. So again, going back, 3 things, if I think about what we want to achieve was, how do you find the main topics of what's going on? We didn't talk about moderating inappropriate content for obvious reasons, because it's very hard to demo that. And the other aspect is how do you find movements. And the 4th part we didn't talk about is how do we understand natural language.